Here we go. So you can put these into your notes however you want. I meant to print off just problems 5, 6, 7, and 8. We already did problems 1, 2, and 3. Those were yesterday when you guys were watching the videos. So that was the first part of the notes. So you guys have already taken that section of notes. So I printed off 5, 6, 7, and 8. That's really where we want to focus. We pick up with problem number 6. We use the graphic organizer. That's the only way I teach it. Overall, it is helpful. And so we start by visualize. Okay? Then we get a formula, we get a function, and then we graph it in this case. So that's what I'm going to do. It says find the dimensions that give the largest area for a rectangle whose base is on the x-axis and whose corners are on the parabola y equals 12 minus 3x squared. And this is why I start out. You must be able to draw the representation of the problem, and we draw it on the x-axis. What shape are we trying to find the area of? A rectangle. The rectangle is inscribed inside of a parabola. This parabola, y equals 12 minus 3x squared. What does that parabola look like? Tell me something about it. It's going down, and where's its vertex? 0, 12. So I'm going to plot 12 up here. I'm going to draw a parabola going down. This will be sufficient to be able to give us an indication of what we need to do for the problem. What should I draw inside of the parabola? What? A rectangle. So if you don't have that picture in your mind as you're starting out, you're really going to struggle doing the problem. Now, what special formula do I have to keep in mind when I do this problem? What's the main thing I'm trying to do? What's my objective? Largest area. So what should I write down? Area equals, I suppose you could take the length of the base times the height. Should we do that? Okay. So we need an expression for the base. We need an expression for the height. This base, if you notice, the corner of this is on the x-axis, is it not? So that is a coordinate. What's the y-coordinate if it's on the x-axis? 0. Do we know the x-coordinate? No, we'll call it x. What would that coordinate over there be? Negative x, because the parabola is symmetrical. We're going to have the same on each side. Negative x, 0. So, A for the day. What is the length of the base if it goes to x on one side and negative x on the other side? (2x). Anybody confused how I came up with 2x? It's a length of x on each side, so that's a total distance of 2x. Any questions? Okay, now the height, that's a totally different story. Would you guys agree that the height would be represented by this y-coordinate? I have an x-coordinate and a y-coordinate. If I have an x-coordinate, how do I determine what the y-coordinate is? If I have an x value, how do you get the y value? Plug it in. Plug it into this, right? See, it says y is equal to 12 minus 3x squared. So if you want to know the height, you're going to plug in x into 12 minus 3x squared. So really, this coordinate is x, 12 minus 3x squared. If you notice, I just rewrote it instead of a y. It says y is equal to it. I mean, that's really my height. Is it not? Whatever the function value is, that's my height. So my height is 12 minus 3x squared. Do we now have enough information to write a function for area? Yes. So the function says the area in terms of what's my variable? X is equal to my base, which is 2x, times my height, which is 12 minus 3x squared. I should simplify that. Let's distribute. What do you get? (24x minus 6x to the third). Is that a quadratic? No, it's a cubic. And instead of the cubic going like that, because it's negative, it goes like that. So the graph is going to look something like that. What part of the graph are we trying to find? The maximum. The maximum occurs at a local maximum spot of right up there. I don't have a way of doing this algebraically. We have to use calculus. Okay, so next year when you guys take calculus, we'll be able to do that using what we call derivatives. So Chrissy will take the derivative instead of equal to 0 and find that spot. That's what we'll do. But in this case, we don't know how to take the derivative. Chrissy, you could if you want to and solve it. But what we're going to do now is we're going to take out our graphic calculator. So take out your graphic calculator. That's our only tool that we know how to solve it right now. Okay, I'm going to turn it on and go to y equals here. And let's type in 24x minus 6x to the third. And I'm going to graph it in a normal viewing window. So zoom 6. Just see what happens. Oh boy. You tell me. Okay, this is important that you think this through. This is kind of tough. The outputs of this graph. What do they mean? What are the outputs? They refer to what in the problem? The outputs refer to area. So all the y values in this graph represent the area. What do the x values represent? Half of that width of the base, right? Well, if you look here, the x values look like they could only be between 0 and 2. Does that make sense that if I have a width of 0 here, or a base of 0, if the base is 0, what's the area going to be? If you have no base, what's the area going to be? And you can see that the graph crosses through 0. How about if I have a base that goes 2 out on each side? If you plug in 2, you get 3 times 2 squared is 12. 12 minus 12 is 0. So your height would be 0. If your height's 0, again, you're going to have 0 for your area. So you can see that that graph tells you that. But I can't see the top of it. Let's change our window to see if we could see the top of it. Which value do I need to change? The y max? Let's move it up to, say, 30. Maybe that will let us see it. Yep, now I see it. How do I find that maximum spot? What do I do with my calculator? Second, calculator trace. Which one do I select? Maximum number 4. I'm going to go to the top. I'm going to go to the maximum. And it says left bound, so I have to go to the left of that maximum. And then I have to go to the right of that maximum. And there I go. I got x is 1.15 and y is 18.47. 1.15, 18.47. That's that coordinate. Let's understand what it means. 1.15 is my x value. 18.47 is my y value, or a of x. So what that means is if I go 1.15 units to each side of the origin, I'm going to end up with an area of 18.47. Has that answered my initial question? My initial question is, what size should this box be? What size should this rectangle be? If x is 1.15, what's the length of the entire base? Yeah, the base is twice x. So the base is equal to 2 times 1.15, which is 2.3. That's the base. How would we figure out the height? It says the height is 12 minus 3x squared. What do I plug in for x? Do I plug in 2.3 or do I plug in 1.15? I plug in 1.15. That's my x value. 1.15 for the height. Let's plug in that, and that will give us the height. (12 minus 3 times 1.15 squared). Enter, and I get 8.03. So 8.03 is the height, 2.03 is the base. Now we've answered the question. Notice, did 2.3 or 8.03, are either of those numbers represented in this part right here? Neither one's there. I have to use that information to eventually solve the problem. Any questions? Not easy, is it? Okay. Let's try a different type of problem. I wonder if we should do problem 8 before we go to 7. Let's go straight to 8. I think that will connect your learning better in this scenario. Similar type of problem. Rectangle is inscribed in a semicircle of radius 16 inches. Let's put together a picture on a coordinate plane again. We're going to start by visualizing it. Then we'll give the formula. Then we'll write the function. And then we will graph it. That's what we're going to do. So, what does this look like? If we put it on the coordinate plane, what shape am I drawing? What's the shape? Rectangle inscribed inside a... So I need to draw a semicircle. It has a radius of... So where's it going to cross the y-axis? Up at 16. How about the x-axis? Negative 16, positive 16, positive 16. So those are those spots. What shape should I draw inside of it? A heart. Nope. Not even close. I cannot figure out how I could give validity to that answer. A rectangle. Thank you for making us smile, Julia. It's very kind of you. Draw my rectangle. What formula should I write down in this box? Area equals base times height. A for the day. What's my base going to be? 2x. This is an x value. This is a negative x value. The distance between them is 2x. Base is 2x. Height. That's an xy value, right? Are you given the function in this problem? No, before, remember, you had y is equal to 12 minus 3x squared. You don't have that anymore. So now what we need to do is we need to write an equation for y equals. Anybody remember what the equation of a circle is? Neither. Remember that? Yeah. What's the center of that circle? HK. What's the center of our circle? 0, 0. So if we just plug 0 and 0 in for h and k, we get x squared plus y squared is r squared. So we're getting closer here. What do they tell you r is in the problem? 16. So it looks like I have x squared plus y squared is 16 squared, or 256. I need to know the height, right? The height can be expressed in terms of y. So I need to solve for y. How do you solve for y? Very good, Hannah. Subtract your x squared. Y squared is 256 minus x squared. Now what? Square root both sides. Y is square root of 256 minus x squared, plus or minus. Now, if you remember, we're graphing a semicircle, and our y value gives us two pieces. Why? Well, because is a circle a function? No. So you can see you have two solutions here. And you know that's because the circle is not a function. So are we talking about the positive part of the semicircle or the negative part of the semicircle? Positive part. So we'll have y is equal to positive square root of 256 minus x squared. That is my function value. So I'm going to go back to my problem, which is right here. And I have y is equal to the square root of 256 minus x squared. We solved for that function. So this semicircle, if you were to graph this on your calculator, you would get that picture of that semicircle. That's what you get. So now we're ready to answer. What is the height going to be then? Very good. Square root of 256 minus x squared. Is anybody tempted to try to take the square root of 256 and x squared? Yeah, you can't do that. Watch. Square root of 25 minus 9. Square root of 25 minus 9, you do 25 minus 9, which is 16, right? Square root of 16 is 4. What you want to do is take square root of 25, which is 5, minus square root of 9, which is 3, and you get 2. That's entirely incorrect. Can't do it. You could square root stuff if it's multiplication in the middle, but not if there's addition and subtraction. You can't distribute powers over addition and subtraction. It doesn't work. That's the best answer I got for you. So we can now write a function. Our function is area. What is our variable? X. What does X represent? The distance that the corner of the rectangle is from the origin. That's what it represents. So area in terms of X is, what's my base? So I write out that formula, base times height. Base is 2x, and my height is the square root of 256 minus x squared. Okay. Is that a parabola? Nope. We don't really know what it looks like. That makes it exciting. Aren't we tired of doing math that we already know how to do? Let's do something new. Yeah! What? Well, no, because you also have this x squared in here. So, I mean, you know, it really looks kind of crazy. So let's type it in. We got 2x square root of 256 minus x squared. And what? Oh, crap. Oh, gosh, I don't see it at all. How about this? How big could this x value be? What's the largest this x value could be? 16. So maybe I should change my window so I can actually see that portion. I'll take my x max and put it all the way out to 16. In fact, I'm going to go a little bit further. I'm going to go out to 20 just to make sure I can actually see it. And then maybe I should go a little bit higher too. Like, what if the box was 20 by 20? Well, then it would have an area of 400. So I at least maybe have a better shot at seeing this thing, because right now I can't see it at all. Now if I graph it, oh, there we go. We have an interesting shape. Heck yeah. Can you find a maximum of that shape? Sure, how do I do that? Calculate, number 4. I'm going to go up to my maximum. Okay, and I need to go to the left. To the left, to the left, to the right, to the right. I don't want to guess. I get 11.31 and 256. So I've got this shape, and that point is 11.31, 256. What does that represent? What does that mean? X is 11.31. That's how far I am on each side. What does the 256 mean? The area, not the height. The area is 256. Do we even know the height at all yet? We don't know it at all. We've got 11.31 for X. We got 256 for the area. We need to identify two pieces. Number 1, the base. The base says it's 2 times X. What's 2 times X? $22.62. How do you find the height? $256 minus x squared, square root of it. This says this is how I find the height. So I take out this guy. I go y equals square root of 256 minus 11.31 squared. And I get 11.31. So 22.62 is my base, 11.31 is my height. That will give me my maximum area. Riz, you had a question that you didn't ask. That shape? That's our graph. So for example, we have a rectangle inscribed inside of a semicircle. And the area formula came up to be this thing. That is what this looks like. That doesn't have anything to do with that picture. Riz, this doesn't have anything to do with that picture. This, yeah, so this shape right here represents the area of the rectangle. Oh boy, look at who's here. Hello. Pause the video, YouTube Nation, hold on. Not an easy problem, okay? You guys, you might have to go home tonight or Sunday or whenever and rewatch these videos. We're doing 7. A hockey team. Who plays hockey around here anyways? All right, so it says a hockey team plays in an arena with a seating capacity of 15,000 spectators. Ticket price is set at $14. Average attendance at recent games has been 9,500. So they got seats to fill. So what he says is a market survey indicates that for each dollar the ticket price is lowered, attendance goes up 1,000. Well, whoever's running this show wants to make sure that they can maximize their revenue. They're not so concerned about filling the seats. They just want to maximize the revenue. So, let's give it a try. How do I determine revenue? In this problem, how do I figure out how much money I'm going to make? The amount of money I make, the amount of revenue, is equal to whatever the attendance is times whatever the ticket price is. Right? And that's an important formula I'm going to write down here. Revenue is equal to whatever the attendance is times the ticket price. So, let's try to do a problem here. Let's figure out their revenue for two situations. Right now, let's figure out what their revenue is. What is their attendance on a given night? 9,500. What is the ticket price on a given night? Right now, what's the ticket price? 14 bucks. And if you take 9,500 times 14, we get $133,000. Now, you know, the owner might say, well, $133,000 is pretty good, but I want to see what the maximum is. Some people would say, I don't care what the maximum is. I just want to get as many people in the stands as possible, so then they'll go buy hot dogs and popcorn and everything else. You know, depends on how you look at the problem. Well, let's make a change here. Revenue equals, let's change this a little bit. Let's change the ticket price. Instead of $14, let's lower it. How much do you want to lower it by? $1. So we'll do a ticket price of 14 minus $1. And if we lower it by 1, what's going to happen to the attendance? It's going to go up by 1,000. So the new attendance will be 9,500 plus 1,000. You see, I don't have a picture here, but I'm still modeling the problem. I'm drawing one example. So if we decrease it by 1 here, it will increase by 1,000 there. Let's see what we come up with for a revenue there. We've got 13 times 10,500. I get 136,500. So, did it go up? The question is, how many times should we raise or lower the ticket price in order to reach our maximum? Well, we now have enough money to try to write an expression for attendance and one for ticket price. Okay? In this case, we had 14 minus 1. I want to write an expression for the ticket price. 14 minus X. So X represents the number of times I lower that ticket price. No, T is the ticket price. I switched the order of these here. I'm sorry. The attendance, we've got 9,500. And what are we adding to that? 1,000 times X. Because, you know, if we increase the ticket price 2 times, then we would add 2,000. If we lower the ticket price 2 times, then we add 2,000 to the attendance. If we lower it 3 times, then we add 3,000 to the attendance. So here I have my attendance, here I have my ticket price. Do we now have enough information to write a function? Yes. The equation, or the function, is R. Revenue in terms of X is equal to, what's my ticket price? 14 minus X. What's my attendance? 9,500 plus 1,000x. I got to multiply all these terms out. Let's start with the first one. 14 times 9,500. We already did that one, 133,000. Now I have 14,000 times 14 times 1,000x and negative x times 9,500. So I have 14,000 minus 9,500. That'll give me 4,500 x. And what's negative x times 1,000x? Negative 1,000x squared. So that's my revenue function. That looks like a difficult one to graph, doesn't it? What's the shape? Parabola. Upside down or right side up? Upside down. That's all we need to do. Let's just draw that. What spot are we trying to find? The maximum, which is the vertex. How do we find the vertex? Negative b over 2a. Negative b would be negative 4,500. 2 times a would be negative 2,000. Negative 4,500 divided by negative 2,000. 2.25. Is that my x value or my y value? X. Do I have to even find the y value? Oh. So it happens when I have 2.25, when I lower the ticket price 2.25 times. The question is, it says, find the price that maximizes revenue from the tickets. Well, my ticket price is 14 minus x. So in order to find the ticket price, I'm going to do 14 minus 2.25. I get $11.75. That tells me the price that is going to maximize my profit or maximize my revenue. And that's that. I don't pretend that these are easy problems, but you guys are able to do the area ones pretty well. After I looked at your quizzes and everything else, you're going to have a chance to practice those. I'm cutting the assignment about in half compared to last year because I interrupted your time with some of my tests. So here's what you have. I'm serious, guys. These problems right here, 23, 24, 27, 30, and 32. So you got, what, 5 problems there? Pretty much they model what we've done in class. Now, if you want more of a challenge, do 29 or 35 and get rid of 2 of those. 29 is a tough problem. But some people get bored with the other ones. They want to try harder ones. Sounds like Casey Gilbertson's taking some of the harder ones. Good for you, Casey. Morgan Haney says she did the harder ones last hour. Ooh. But you guys, I'm going to warn you, if you let this sit all over break and then come back on Monday, because we're going to test next week. We got one more section to cover, and that's on inverses, then we can test. If you let this sit the whole week, you're not going to remember how to do it. So you got to get rolling. Good luck.